Hi friends, good evening. Hi, how are you all? Very good evening to you all, my dear friends. Hope you are doing fine. Any development after Monday? How many? Hi Mansi, good evening. Jitesh, very good evening. Still waiting for the place to join the game. How are you Jitesh doing? Mansi. Jitesh, how is the preparation for the coming exams? Mansi, how many problems did you solve? Still we are waiting for Radhika. Radhika joined the game. Akshay, very good evening. Radhika, very good evening. Akshay. Apeksha, where are you? Josna, waiting for you. Pratap Singh. Any development after that? After Monday class, how many problems you all have solved related to this currently going on topic? Hi Akshay, very good evening. Yeah, today let us see the questions, the list of questions which I had given. In that many students have committed wrong regarding this problem. When you look into this problem, we have placed three rods, one along x-axis, other along y-axis, and third one joining both the rods. And I asked you to find the center of mass. Many students have done wrong. Most of the students have done wrong. Now, how to handle this problem? Now, I told you, for a linear system, its center of mass is at its center. You feel each rod as a center of mass, as a point mass, and you have to assemble them like this. Fine, Akshay. So, you have to place them on the coordinate system like this. One is here, other is here, and third one is here. So, when you observe the particle on the x-axis A0 and particle on the y-axis 0 comma A by 2, and this one, its coordinates are A by 2 comma A by 2. These are the coordinates of the system. Akshay have done around 20 questions of this topic. Really great, Akshay. I keep it up. So, there are three particles with identical masses, M, M, M. And we know that according to the discrete particle system, when particles are assembled in the plane, they have x coordinate of the center of mass, y coordinate of the center of mass, x coordinate of the center of mass, m1 x1 plus m2 x2 plus m3 x3 by total mass, y coordinate of the center of mass, m1 y1 plus m2 y2 plus m3 y3 by m1 plus m2 plus m3. Finally, the result is a by 3 comma a by 3. This is the way how to handle. Don't feel it as a rod, feel it as a particle. Hi Adina Vishnuvardhan Reddy, after a long time. Reddy, where were you during all these days? Very good evening to you. How are you? So, this is the way how to handle this problem. I hope now everyone has got the clarity. And a recap of the previous class. We were yet to start the motion of the center of mass, and we finished the center of mass of the continuous mass distribution, and we covered extensively the number of problems. Now, goals of the today's session: motion of the center of mass and followed by numericals. After that, a very important concept you will get in the problems. a sphere is cut and removed from the main sphere, what will be the shift in center of mass? And a circular disc, small disc is cut and removed from another small disc. Where is the location of the center of mass? How it shifts? Like this type of models we used to get. For that, now today's session we are going to deal. Now, motion of the center of mass. Till now we dealt with the discrete particle system. Before going to the motion of the center of mass, position vector of the center of mass, RCM bar. Now we are entering into the vector notation of the center of mass. M1 R1 bar plus M2 R2 bar, so on, Mn Rn bar by total mass. This is the vectorial notation of the center of mass. Now we have entered the dealing center of mass with vectorial concept. RCM bar is equal to M1 R1 bar plus M2 R2 bar, so on and so forth. Velocity of the center of mass. When you differentiate this above equation, d by dt of RCM bar will give you 1 by m into M1 V1 bar plus M2 V2 bar, so on, Mn Vn bar. This is the velocity of the center of mass. Then acceleration of the center of mass, ACM bar, d by dt of VCM bar, that is equal to 1 by m into M1 A1 bar plus M2 A2 bar, so on, Mn An bar. That is the acceleration of the center of mass. This VCM multiplied by m, mass multiplied by velocity, will give you the momentum. Momentum of the center of mass, PCM bar, is equal to m into VCM bar is equal to M1 V1 bar plus M2 V2 bar dot dot dot, so on, Mn Vn bar. That is the momentum of the center of mass. Next, this ACM bar into m, mass into acceleration, will give you the force. Force acting on the center of mass, FCM bar, is equal to F1 bar plus F2 bar, so on, Fn bar. So these are the valid equations for problem solving. And in the earlier classes I told very clearly, the center of mass can only be affected by the external force. Internal forces will not have any role in varying the center of mass. Another point I told, if two bodies are moving towards each other because of their mutual attraction, in that case center of mass has nothing to do. Mutual attraction is an internal force, so it will not affect the center of mass. Keeping all these points in mind, now let us add a few examples. Let us see the problems based upon the motion of the center of mass. I am giving a pulley system. Here I have taken a Atwood machine. I hope you know this machine is called as Atwood machine, provided with two blocks M and 3M and suspended to a point by a spring. And when the system is released, we know the body with mass 3M will be moving in the downward direction, and the other body having the mass small m will be moving in the upward direction. Now my requirement is, what is the acceleration of the center of mass of this system? What is the magnitude of the acceleration of the center of mass of this system? Here system, why we call? Because it is associated with two blocks M as well as 3M. We know that 3m will be moving in the downward direction, m will be moving in the upward direction. Now your time starts. I want the acceleration of the center of mass of this two block system connected with a pulley through a spring. Now your time starts. Find the acceleration of the center of mass of the given system. Your time starts was Mansi, Josna, Akshay, Vishnuvardhan Reddy, Radhika, gear up. Today Apeksha is absent. So gear up for the problem and declare the answer. We are all eagerly waiting. Radhika declared her answer as J by 2. Jitesh declared his answer as 0. Very good, very enthusiastic Radhika and Jitesh. Still I am waiting for few more answers from the Mansi declared her answer as G. Why? Still. Pratap Singh I think today is absent. Vishnuvardhan Reddy, I am waiting for your answer. And others, Akshay, I am waiting for your answer. Akshay. Mansi declared her answer as G. Radhika came out first with her answer as J by 2. Still few more answers I am expecting. Time is running out. Yes, time is up. Yeah, now let us see which is the right answer. In Newton's laws, you may be knowing this is a simple pulley system. There we had a shortcut for computing the acceleration of the each block. Akshay declared his answer as 3 by 2. And I am giving a shortcut. Acceleration of this each block is NPF by Tm. NPF means net pulling force. 3m is pulling in the downward direction. M is also pulling in the downward direction. How to write a net pulling force? Bhagyasri, fantastic Bhagyasri. She declared her answer as G by 2. Now let us see who is the winner. Net pulling force, strong force, 3mg minus weak force, mg by total mass, 4m. This is equal to 2mg by 4m. That is nothing but G by 2. This is acceleration of the each block. I clubbed Newton's laws with center of mass concept. So you have done up to this and you declared the answer. If I ask the question as what is the acceleration of each block, then J by 2 is the correct answer. But my question is not that. What I asked, what is the acceleration of the center of mass of the system is my question. Just now I told center of mass of a system m1 a1 bar plus m2 a2 bar, so on mn an bar by total mass. Here 3m into, I write this as a1 and m into a2 by 4m. As per the formula, acceleration of the center of mass is equal to m1 a1 plus m2 a2 by m1 plus m2. That is 3m into G by 2. 3m is coming in the downward direction, m is moving in the upward direction. We know that acceleration is a vector quantity. You have to differentiate their motions by putting negative sign because it is moving in the upward direction. If I consider the downward acceleration as a positive, I should show upward acceleration as a negative. M into G by 2 divided by 4m. mm cancelled. 3g by 2 minus g by 2. How much? 2g by 2 by 4. Answer is equal to g by 4. Acceleration of the center of mass is not g by 2. It is g by 4. Please clear your conceptual blocks. This is the way how to handle this problem. Acceleration of the center of mass for the two block system. Here I have not asked the acceleration of the individual block. I asked the acceleration of the center of mass of the system. So the Radhika came out finally with a J by 4. So the correct answer is, as I have done on the board, it is equal to G by 4. So you got the clarity of handling this problem. Now I will take you to another problem. Problem number 2 on the motion of the center of mass. Please be confident in the concepts so that you can handle any problem. Two persons of masses 55 kg and 65 kg are at the opposite ends of a boat. Length of the boat is equal to 3 meter and it is weighing 100 kg. Now 55 kg man walks up to 65 kg man and sit with him. If the boat is in still water, then center of mass shifts by how much? I am reading the problem. Two persons of masses 55 kg and 65 kg are at the opposite ends of a boat. Length of the boat they mentioned in the problem as 3 meter and it is having a weight of 100 kg. You know, after some time what happens? 55 kg man walks up to the 65 kg man and sit with him. If the boat is in still water, then center of mass shifts by how much? Now your time starts. Get up. Bhagyasri, Adina, Akshay, Mansi, Radhika. Now your time starts. Crack the problem. Radhika came out with her answer as 0. Still I am waiting. Still I am waiting. Radhika's answer is 0. Still any more answers? Once again check, Radhika, before you declare the answer. Once again check. Mansi, where is your answer? So Radhika gave the explanation for answer also. External force on the system is 0. So center of mass shift is 0. That was her analysis. Still I am waiting for few more analysis. Bhagyasri Dalvi also came out with a 0. Then till now no response from the boys end. Vishnuvardhan Reddy, what is your answer? The answer enta, Vishnuvardhan Reddy. Jaldi, I am waiting for your answer. Jitesh, where are you, man? Yes, the time is up. Mansi came out with an answer of 0.12 meter. Good calculation, Mansi. Still, few more seconds I am extending for any other answers from the boys' end. Akshay. Okay. Just now I told the concept. When two persons or two particles are moving towards each other, then it is their mutual interaction without the agency called as external force. And already it is mentioned very clearly in the problem. If the boat is in still water implies water at rest, no floating, means initially center of mass is at rest. Initially center of mass at rest. Now if the persons are moving towards each other, and if one person is moving towards other person, center of mass will not worry about it, because as long as external force is not working on the system, center of mass will remain unaltered. So here initially center of mass is at rest, it continues its status as a rest, so the shift in center of mass will be equal to 0. The correct winner for this problem, Radhika, followed by Bhagyasri Dalve. Good analysis, Radhika and Dalve. Fantastic analysis. This is the way how to fill up the gap between the application and the concept. You have to develop a bridge between the concept and application, so that nobody can beat you in physics. Physics is a subject always where whatever the ideas you know, you have to put them in the practice, called as the application. Fantastic, Radhika, keep it up. Again you came back into the game. Now I am taking you to the another example. Numerical problem number 3 on the concept called as motion of center of mass. Two blocks M, 2M are connected by a spring of constant K, and they are moving with a velocity v naught. The body with more mass collides elastically with another block (2m) at rest. Figure is like this: M, 2m, system is moving with a velocity v naught. There is another block 2m, A, B, C. Question number 1. Find velocity of B just after collision. Find the velocity of B just after collision. This is a problem. Two blocks M, 2m are connected by a spring of constant K, and they are moving with a velocity v naught. The body with more mass collides elastically with another block 2m at rest. Find velocity of the block B just after collision. Question number 2. Find velocity of center of mass. Find the velocity of center of mass of the system. These are the two questions. I am narrating the problem. Two blocks M and 2m are connected by a spring of constant K, and they are moving with a velocity v naught. The body with more mass collides elastically with another block 2m at rest. Find the velocity of the block B just after collision, and after that find the velocity of the center of mass of the system. Bhagyasri Dalvi came out with her option as V0 by 2. For the first question, she came out with the answer V0 by 2. I hope it is the answer for the first question or second question, Bhagyasri. So here I mentioned two questions. Question number 1, velocity of B just after collision, and question number 2, velocity of the center of mass of the system. These were the questions. Bhagyasri Dalvi declared another answer. It would arrive just after collision. She declared that. Still any more answers I am expecting. B is colliding with C, and the first question, velocity of the B just after collision, and find the velocity of the center of mass of the system. These were the questions. Still any other answers? I am waiting here. Mansi, Radhika, Vishnuvardhan Reddy garu. Still other players, what are you are all doing? I want the velocity of B just after collision, and find the velocity of the center of mass. Radhika declared her answer as 0 for the question 1. Vishnuvardhan Reddy declared his answer as V. And I also want the velocity of the center of mass of the system. V for 1, first question he declared. Still any more answers? Yeah, your time is running out. I am giving few more seconds. I want the velocity of the B just after collision. Velocity of the B just after collision, and velocity of the center of mass of the system. Radhika, what is the answer for the second question? Second question, Vishnuvardhan Reddy declared his answer as V by 5. Vishnuvardhan Reddy declared his answer as V by 5. Your time is up. See, in elastic collision we know that momentum of the system before collision will be equal to the momentum of the system after collision. And when you observe this collision here happened between this block and this block. Already it is mentioned that this block is at rest before collision and this block has a speed of V naught. Momentum before collision will be equal to momentum after collision. And moreover, when the masses of the bodies are identical, in elastic collision, what you observe is interchange of velocities. After colliding with 2m, block B will be losing its velocity to the block C. And block C velocity is V naught and block B will be coming to 0. So, the velocity of the block B just after collision will be equal to 0 according to the conservation of momentum. Conservation of momentum, if you give the mathematical equation 2m into V naught is equal to 2m into it transfers its entire velocity to the other block and it is coming to the rest condition. We are having this V1 is equal to m1 minus m2 by m1 plus m2 into u1. This is a mathematical verification. And V2 is equal to 2m1 by m1 plus m2 into u1. So, when you substitute in them, you will get the velocity of the block B will be equal to 0. That is the answer for the first bit. Second bit, I have asked the velocity of the center of mass of the system. Velocity of the center of mass. How many blocks are there in the system? Totally there are 4 blocks. m1 v1 plus m2 v2 plus m3 v3 divided by total mass m1 plus m2 plus m3. Now, m1 is equal to mass of A into its velocity V naught, m2 2m into its velocity V naught, m3 anyway at a rest condition by m plus 2m plus 2m. So, this vanish 3m into V naught by 5m, mm cancel, 3 by 5 V naught. That is the answer for the second question. Velocity of the center of mass is equal to 3 by 5 V naught. Please clear your blocks, clear your conceptual blocks. Many have no one has given the correct answer for the second question. They just now I have taught you the concept m1 v1 plus m2 v2 so on and so forth by total mass. m1 is m, its velocity v naught, m2 is 2m, its velocity v naught, m3 is 2m, but its velocity is 0 by total mass m plus 2m plus 2m, 3 by 5 v naught. I will proceed to the next concept. Very good, Vinayak, very good. Please clear your conceptual blocks. Now, I am taking you to the another concept. Suno, take se suno. Listen very carefully. Shift in center of mass. Say for example, we are having problems related to shift in center of mass in JEE as well as NEET for 2-dimensional objects as well as 3-dimensional objects. I am briefing about the concept. Generally, the problem will be fired like this. From a disc, another small disc is cut and removed. From a square plate, another small square plate is cut and removed. And from a sphere, another small sphere is cut and removed. When entire sphere is as usual, when entire disc is as usual, its center of mass is as per its shape and size. The moment you remove a part of that main body, automatically center of mass will not be there. It has to be shifted. So, when it is shifted, the questions will come as how much is the shift in the center of mass and what should be the direction of the shift in center of mass. For 2D I am giving a shortcut. Shift in center of mass delta x is equal to removed area by remaining area. When you deal with two-dimensional objects, you have to deal with the area only. Removed area by remaining area into distance between the two centers C1 and C2. C1 is the center of the entire body before cutting. C2 is the center of the body that is cut. So, shift in center of mass will be obtained by the equation removed area divided by remaining area into distance between the two centers. For 3D objects like sphere, cube, a small sphere is cut and removed. How should be the center of mass shifted? For them you are having removed. 3D means volume comes into action. Removed volume divided by remaining volume into distance between the two centers C1 and C2. So, keep these two equations in mind and let us get up for the problem. Once again, brief review. For 2 dimension, removed area by remaining area into C1, C2. For 3 dimension, removed volume by remaining volume into C1, C2. Now it is the time of the first numerical. Circular plate of of thickness D is equal to circular plate of uniform thickness has diameter equal to 56 centimeter and a circular portion of diameter 42 centimeters is removed from it from one edge. Then shift in center of mass is equal to, I am narrating the problem. Circular plate of uniform thickness has diameter equal to 56 centimeter and a circular portion of diameter 42 centimeters is cut and removed from it from one edge. Then shift in center of mass will be how much? This is the numerical based upon the concept just now I fed you. Circular plate of uniform thickness has a diameter 56 centimeters and from it a circular portion of diameter 42 centimeters is cut and removed from where? From one edge. Then shift in center of mass is equal to how much? Your time starts. Jaldi. Time is running out. Your time is running out. Be fast. Be accurate. I will see who is going to apply the concept for cracking this problem. Who is going to apply the concept for cracking this problem? Uniform thickness has a diameter equal to 56 centimeter and another portion of diameter 42 centimeters is removed from it. From where? From one edge. Then what will be the shift in center of mass is the question. I hope everyone is very busy in cracking the problem and everybody is trying to give the answer very fast relative to others. So this time I am eagerly waiting who bridged that gap between the concept and application. Maybe many players are coming into game day by day. Today I think Josna is absent, am I right? So who is the winner of this problem? Who will be the winner? Your time is up. Your time is up. So, shift in center of mass, as it being the two dimension, removed area divided by remaining area into C1, C2. They mention the diameter of the smaller one removed is equal to 42. So, radius is equal to 21. Pi into 21 into 21 by remaining area pi into 28 square minus 21 square, and the distance between the two centers. This is a big plate. And this is a small plate. And from here to here it is given as 21. And from here to here it is given as 28. So, the radius of the big plate is RB is equal to 28 and R small is equal to 21. So, the distance between the centers is equal to 7. Pi cancel out. 21 into 21. A square minus B square can be written as A plus B into A minus B into 7. 21, 21, 7 by 49 into 7, cancel out. The answer is equal to 9 centimeter. The correct answer is equal to 9 centimeter. Removed area. Radhika, be clear. Akshay came out with correct answer. 0.09 meters. Exactly, Akshay. Fantastic. Devyani, hello. How are you? So, the removed area pi into 21 square by remaining area pi into Vishnuvardhan 9. Correct answer. Pi into 28 square minus 21 square into distance between the two centers. The distance between the two centers is equal to difference in the radii. Radius of the big plate 28, radius of the small plate 21, gap between them C1, C2 is equal to 7. So, the correct answer is equal to 9 centimeters. And a few more applications I am feeding. From a big plate of radius capital, another small plate of radius smaller is cut and removed. Find the shift in center of mass. And another problem, from a circular plate of radius capital, a square portion as shown in the figure is cut and removed. Find the shift in center of mass. Another problem, from a square plate of side length 2L, a circle from a corner quadrant is cut and removed. R is the radius of the circle. R is not given, you have to find it out. Then what is the shift in center of mass? Another one, from a square of length 2L, another small square is cut and removed. Find the shift in center of mass. Another one, from a square, a circle is cut and removed. Find the shift in center of mass. Next, from a square a triangle, plate is cut and removed, find the shift in center of mass. These are the questions which you are supposed to get up. So once again I am showing all the figures based upon the shift in center of mass. This was the first question. From a circle of radius capital. So Radhika, don't worry, small mistakes are in applying C1, C2. Yeah, that is the reason. You must be very careful in identifying the center, distance between the two centers. So in the first case, a small circle, small r is cut and removed. In the second case, from a circle, a square is cut and removed. In the third case, from a square, a circle is cut and removed. And again, from a square, another small square is cut and removed. From a square, a triangle is cut and removed. These are the problems I have given you for practicing on the concept which I just told. In question 6, what is the given side of the small square, Akshay? That is, I have given the figure. From that figure only, you have to obtain what will be the side of the square. I have shown very clearly, it is cut from the corner, and the side of the main square is given as 2L, like that. Now, previous class contest question, work done by the gravitational force in one revolution of the earth around the sun in its elliptical path is equal to 0, because the displacement is for a closed path, as you are all well versed, displacement will be equal to 0. Therefore, work done will be equal to 0. Work done will be equal to 0. It's very amazing. Why you have not handled this problem? You can easily handle this problem because you are now doing very, very tough problems. It is an LKG and pre-nursery problem for you, in my opinion, because you are all very gigantic personalities now in handling the physics problems. It is a small Lilliput problem. Displacement is equal to 0. As per the reports, it is mentioned that no winner is there. Very sorry. And the next one. And this is the today's contest time. This phi is equal to moment of inertia. Capital is equal to radius of the pulley. Capital being the radius of the pulley and I being the moment of inertia. Then you are asked to find the acceleration of the system of two blocks, capital M and small m. You are asked to find the acceleration of the two blocks, capital M and small m, mentioned in the problem. What are the things they are mentioned in the problem? The things mentioned in the problem are that the moment of inertia is given. Whatever your answer, that should be mentioned in the form of the given variables. You are not supposed to handle with your own variables. So whatever the variables mentioned in the diagram, you have to go through them. The variables are moment of inertia is mentioned, followed by the radius of the pulley system is mentioned. From these two things, you are supposed to retrieve your answer. That is nothing but find the acceleration. If I is equal to moment of inertia and r is equal to the radius of the wheel in the pulley. Thank you for joining. I have given fantastic 10 problems. You try to solve those problems and don't try to leave anyone. Try to crack every problem. I will be with you till you enter into JEEs and medical colleges. And today's brief recap. Thanks for joining us. Have a good day. Thanks a lot.